Greetings folks, it's Naveen joining the call. I hope you're able to hear me, and today we'll go ahead and have a look at some of the aspects of our Hadoop training. Go ahead and see where this is. Okay, so just give me 1 second while I adjust my screen here. So there's my screen, it looks good. Let me go ahead and bring it up. Alright, welcome again folks. My name is Naveen, and here's my plan. I'm gonna go ahead and give you a brief introduction about myself, and then we'll go ahead and see what are the different modules that we have in our Hadoop development. Let me go back to my PowerPoint. Alright, and what I'm looking for is I'm trying to open my tool here so that I can give you a brief overview. So here's my plan, guys. Today I'm going to give you a demo of Hadoop development course at Kernel, and my focus is I will start with a brief introduction about myself. Then we will go ahead and discuss about some of the main modules that we would be covering in our course, and then we will go ahead and try to understand what is big data and Hadoop. Then we will try to understand why Hadoop is used, and then we'll look at a few scenarios how Hadoop is used in real world, and we'll have a look at our final banking project that we would be doing as part of this course, guys. Okay, so this is a plan for today, and let me go ahead and get started with my introduction here. Okay, my name is Naveen, guys, and I have 18 years experience. Around 10 years I lived in US, and about close to 8 years, last 8 years I'm here at in India. Cool. And last 2 to 3 years I've been involved in big data and data science technologies, and big data and data science domain and Hadoop technologies, guys. Okay, so this is a brief introduction about myself, so let's go ahead and move on here, guys. Okay, so with that, there's a kernel training. For any additional information, for any additional questions, please feel free to reach out to us at the website, and we will share with you the email information shortly, guys. Okay, so there's our Hadoop, guys. So before I go on to what is big data, let's go ahead and have a quick look at our course content, and then we'll come and have a look at big data and other concepts, guys. Okay, so here is our plan, gentlemen and ladies. It's going to be a 6-week course, and we have about 12 modules here. At a high level, these are the modules, guys. Okay, week 1, okay, we'll cover module 1 and module 2. Each module is about 3 hours, and we'll focus on big data and Hadoop introduction. We'll try to understand Hadoop cluster architecture and MapReduce concepts in the first week. Then we will go ahead and get into advanced MapReduce concepts and Hadoop 2.0, which is Yarn, guys. You know, that is what we'll focus in the modules 3 and 4, which is the week 2. Then in week 3 we will focus on Pig and Hive, and in a minute I will show you the details of the details of the subtopics. And week 4 we will go ahead and cover HBase and Sqoop, guys. Okay, and coming to week 5 we'll focus on Flume and Uzi, and a final project in Hadoop, which is the complete banking project, guys. Okay, final project in banking domain, how Hadoop is used and how it is useful and things like that. And then in 6th week, one of the tools which is receiving a lot of attention is Spark, guys. Okay, so we're going to go ahead and look at some of the fundamentals of Scala and Spark in this one, because it will be useful for you guys. As my we have designed it so that it will be useful for you guys. Okay, having said that, here's what I got in my first module, guys. So what I'm gonna do is I'm gonna select this. These are the topics that I will be covering as part of my first module. We'll again get into what is big data, what are blocks, replication, fault tolerance. These are the fundamental principles of Hadoop. In module 2, let's go ahead and see what we have. Let's select that. So that's module 2, guys. We will go into the architectural concepts of the Hadoop cluster, and we will get into the MapReduce overview. We'll start with that. We'll try to understand what is MapReduce here. Then in week 3, wrong selection, so good down. Okay, so that's week 3, guys. We'll get into some of the advanced MapReduce concepts. This is going to be a bit into Java, guys. Okay, the advanced MapReduce is completely going to be a Java-oriented concepts. Other than this one, the others are don't have much of Java, but this is the only one which have a lot of Java, guys. Okay, and in the module 4, we'll look at some of the configurational details. We'll try to understand how to look into the planning of the cluster. How do you design a cluster? And the different aspects of how do you choose hardware, software, and the log files and things like that from an administration standpoint. Those are strictly administration stuff, guys. Okay, and then we'll get back into our Hadoop and Yarn, and in this one we'll look at the new things which have been introduced in Hadoop 2.0 and Yarn. Okay, and coming back to Pig, that's what we have. These are the topics that we would be covering in Pig. We got a bunch of good examples. How do you deal with complex data types, built-in functions, the multiple data set operations and things like that. And oops, okay, so move on here. And in Hive, here are the topics that we would be covering, starting from fundamentals to dynamic partitioning. And in week 4, we'll start with the CAP theorem, try to understand what's NoSQL and the different aspects of HBase, and followed by Sqoop, where we'll try to understand the different aspects of what is Sqoop and things like that, guys. Okay, and then in the week 5, that's what we got. We'll focus on Flume and Uzi, how it is useful, and we'll try to understand a scenario from a JSON semi-structured data, how you would go ahead and convert it into convert and use it in a real world in a big data scenario. And Uzi is a workflow orchestration tool. We'll just have a brief talk about it in a bit. We'll try to cover a few exercises in that also. And there's the final project in banking domain. We'll try to understand what is the problem, what is the objective, what is going to be our objective, how do we go ahead and come up with a solution, the architecture, and that should give you a pretty good idea about the real world scenarios, how Hadoop fits in. And we have different tools working together here, guys. Okay, right from HDFS to Pig, Hive, Sqoop, HBase, so all these things come in here, and I'll give you a brief introduction towards the end of this session today. Okay, and during the week, module 11 will cover the fundamentals of Scala, and in Spark we'll go ahead and cover these things. We'll try to understand what is Spark, how it is useful, and things like that. Spark is itself a whole new course, so for this one we will go ahead and focus on an introduction, and that should be pretty much helpful and useful to you guys. Okay, so that is the plan, guys. So let me go ahead and save this one, come back here. So if you guys are ready, we can go ahead and get started with what is big data and Hadoop, guys. Okay, so let me go ahead and bring up my tool here. Alright guys, so the first thing we'll try to understand is what is big data, guys. Okay, from this screen, what we are looking at is, here is what is going on, guys. Okay, if you take the total amount of data that we have generated right from the beginning of time till 2003, it's supposed to be about 5 exabytes, guys. Okay, you may have an idea already that 1 terabyte equals to 1000 GB. Okay, you may also have an idea 1 petabyte equals to 1000 terabytes, and then comes 1 exabyte, which equals to 1000 petabytes, guys. Okay, and then we have something called 1 zettabyte, which equals to 1000 exabytes. All right, so that's what we have. So what are we looking at here? Well, this is the total amount of data that the mankind has generated up to 2003. What happened in 2012 is we have generated about 2.7 zettabytes of data, guys. Okay, what does that mean? Well, take a look at this one. I'm going to go ahead and select this. I'm going to type it. See this one? If that is the data that we have generated in 2003, this is the amount of data, which is 5 exabytes, then just in 2012 we have just generated that amount of data. Okay, if you compare this one with this one, what we are looking at is not double, is not triple, is not 10 times, is not 100 times, guys. What we are really looking at is an exponential volume of data which is getting generated. Okay, so just give me 1 second. Okay, so at a fundamental level, guys, okay, so let me go back here. At a fundamental level, what we are looking at is the volume of data which is getting generated is as I said, it's exponential, guys. Okay, the second thing, if you compare again the volume of data that is generated in 2012, right, what is happening is it's about this amount of data. Let me come back here one more time. Okay, this amount of data, which is that one, is getting generated every 2 days in 2012, guys. Okay, so one more time, I'll go ahead. Fundamentally, we are looking at volume of data, which is exponentially huge, and when we say that it's that amount of data which is getting generated every 2 days, right? What do we mean by that? Well, we are saying that the speed at which we are generating the data, okay, that is the second aspect of it, is what you can think of. All right, so what is that? Well, that is the velocity. The velocity of the data that we are generating, the rate at which we have started generating that amount of data, is really huge, guys. Okay, why is that amount of data we are generating in 2012? Because of sites such as Facebook, LinkedIn, Twitter, and social networking sites, and all kinds of sites, guys. These are the sites where a lot of people use them because they are simple, they're easy, and they are about sharing. Right, a lot of people like to share, about their experiences, about the products and things like that they purchase or may have dealt with. Right, so as a result of that, if we put together all this data, that is the data that we are talking about, guys. Okay, so while these are 2 V's, there is one more V, guys. What is that? It is a variety of the data. All right, so if I go here, on Facebook you may find XML data, on Twitter you may find JSON data, on social networking sites you may find data in some other format, and so on, guys. Okay, what is happening? Well, that is the different varieties of the data. What does that mean? Well, there is a third aspect. See if I can put here. The third aspect is the variety of the data that we are dealing, guys. Okay, at any point of time, if you get a question, what is big data, it equals to 3 V's, guys. Okay, a short and a sweet answer is 3 V's. What is the first V? Well, that is the volume. Why? Again, the amount, the volume of the data that we are generating today, right from 2012, every 2 days we are generating the entire data that the mankind has generated up to that point. Okay, that's really huge, guys. Okay, so we are referring to the volume. Then when we say this is the amount of data that we are generating in just a span of 2 days, right? What does that mean? Well, that is the velocity. The rate at which we are generating the data is really huge, guys. Okay, that is the velocity. Then comes the variety. What is the variety? Well, different websites have the data in different formats, right? What do companies want to do? Today, companies want to go ahead and get the data, access the data, download the data, store the data, process the data, and understand. What is it they want to understand? Well, what are the customers talking about our products, about our services? What are their experiences? Are they good? Are they neutral? Or are they bad? If they are good and neutral, nothing to worry, guys. But if they are bad, they want to understand what is it that they are unhappy about, and they want to do something about it. We'll look at an example of that in a minute, guys, but that is what the variety refers to. All right, so short and sweet, what is big data? Again, big data refers to those 3 V's. Okay, so I hope that is making sense, guys. Okay, and here is an example of the different varieties of the data, guys. Let's go down. So the structured data, that is the data which is there in your, come back here, which is there in your different kinds of databases. And then you have semi-structured data such as, you know, XML, JSON. There's some minimal structure associated with them, so that is referred as the semi-structured data. And then you have your plain log files where there is very minimal structure which is associated. Even plain text could also be referred as what is called completely unstructured data, guys. Okay, these are the different kinds of structures of data is what it is about. All right, moving on. Now today, as I indicated earlier, many companies, they are interested in accessing this data, storing the data, and getting some insights out of the data, guys. Okay, generally what is happening is, imagine you're working in a Java or a .NET company. Okay, generally what you'd have, well, any company would have an Oracle or a SQL Server or a MySQL database. Then you'd have different layers, guys. Okay, see this one, this is your data access layer, this is your business layer, this is your service layer, and there is your UI layer. Okay, so let me go ahead and see if I can indicate it like that. That's my UI layer, that's my service layer, that's my business logic layer, and that's my data access layer, and that's my database, guys. Okay, what happens? Well, we write some stored procedures, we get the data from database to data access layer, then we build the data objects, then we return it to the business layer, then we build the objects, we return it to the service layer, and from the service layer we go ahead and return it to the UI layer. At the UI layer, what is happening? Well, this is where our users are. They're accessing the data, and what do they come up with? Well, they come up with useful insights. What is an example of an insight? Well, it might be, you know, they looked at their application and they figured out, hey guys, you know, it looks like, you know, they're a garments company, and they have observed that their customers, most of the purchases in their company are being made during the weekends between the age groups of, you know, let's say 13 to 21. What does that mean? Well, the teenagers are making most purchases during the weekends. Okay, so that is kind of an example of an insight, guys. Okay, but today what is happening? Well, here's what is happening, guys. There is a new database around. What is that? That's your internet. Go down. And what do you have on the internet, guys? Well, we have different kinds of sites. Okay, so one is Facebook, another one is Twitter, another one is, let's say, social networking sites, and so on. Different kinds of sites. And what do we have? Well, Facebook, let's say, has the data in the form of XML. Twitter has their data in JSON and many other formats. Okay, what do companies want to do? From their UI layer, they want to access the new database. Your internet is becoming your new database, guys. Its data is there in multiple varieties from various sites. Okay, why is this data important? Because our customers, they are chatting, they're communicating on these sites, saying that, you know, about their experiences about the products and things like that. Okay, by getting those insights, right, by getting those insights, it helps companies in making some very useful decisions, guys. Okay, so in trying to understand, so if your database is much smaller, or let's put it like this, guys. Okay, a database is like the rivers in the world, guys. Okay, whereas the data in your internet is like the seas and oceans. If you are able to find some useful insights in the rivers of the world, right, we can find, it's like if you're able to find fish in the rivers of the world, you will be able to find lots of fish in your seas and oceans, guys. Okay, what is the fish? Well, that is the insights. That is the insight and the knowledge we are talking about. We'll talk about more in a minute, but I hope that is making sense, guys. Okay, so having said that, let's move on here. Let's have a quick look at what is Hadoop, guys. Okay, so let's come back here. So until now, what we have really looked at is we try to understand what is big data, guys, and short and sweet, it's about 3 V's. Then we have looked at what's called the traditional architecture. Traditional architecture, what do you have? Well, you have something like a database, then you have something like a data access layer, then you'll have a business logic layer, then you'll have a service layer, then you'll have a UI layer, guys. Okay, your data, this is like an example of a entire architecture or a service layer or service oriented architecture. Okay, but what is happening today? Well, the data in the database is much smaller, and what companies are detecting is, if they can get insights from database, they can get lots of insights from a new database. What is that? That's your internet, guys. Okay, internet is becoming your new database. Okay, that's the thing. And what's there on internet? Well, there are many sites there, and these sites have lots of variety of the data. So now your database has a lot of varieties of the data, and if database is like the rivers where you can find the fish, then internet, which is a new database, is the seas and oceans where you can find lots and lots of fish. That means lots and lots of insights could be found on the internet, guys. Okay, so that's a quick summary of what is big data. And again, why 3 V's? If you remember, the amount of data that we are generating today has grown exponentially, guys. What we have generated, what the entire mankind has generated up to 2003, today we are just generating in 2 days, guys. That is why the volume is becoming very important aspect, and the rate at which the data is getting generated from these sites and other sources is becoming very important. And the variety, guys. Okay, the YouTubes, the audio, video, and everything that is getting and moving around is also part of the variety of the data, guys. Okay, I hope that is making sense, guys. Now, with that as a background of big data, let's try to understand what is Hadoop, guys. Okay, so let's go here. So Hadoop is a solution for what is big data, guys. Okay, and Hadoop is open source. That means it's free. It's Apache license, so in other words, it's free. It provides us a framework of tools, guys. Okay, let's try to understand what is a framework of tools. Okay, so okay, at a fundamental level, guys, Hadoop is nothing but a distributed file system. What is a distributed file system? Well, you can think it's a group of computers together. They act as if they are one computer, guys. Okay, that is what a distributed file system is. What does that mean? Let us say if I have one file on this computer, okay, and we go ahead and log into this computer, then I will be able to see this file. Why? Because they're acting as one computer. The magic is taken care of by the distributed file system, guys. Okay, the distributed file system, the Hadoop distributed file system, which is referred as HDFS, guys. Okay, it is the brain of Hadoop. All right, and then on top of Hadoop you have another layer sitting. In HDFS we store the data, guys. Okay, if you want to process or analyze the data, how do you do that? Well, that's where comes in the MapReduce framework. What will MapReduce framework do? Well, you have different kinds of data in Hadoop. You store different kinds of data in different nodes in Hadoop. If you want to read the data, right? If you want to read the data and you want to process or analyze the data, we will use MapReduce framework, guys. MapReduce is the heart of the Hadoop. You can kind of compare pardon me. Okay. Sorry about that, guys. Pardon me. You can kind of think, if there are thoughts in our brain, then we use our heart to analyze our thoughts. That's why we call the MapReduce as the heart of the Hadoop, guys. Then you can think these are the Hadoop has a couple of eyes. What are them? Well, one of them is Hive, and another one is Pig, guys. Okay, what does Hive do? Well, Hive will take SQL statements as input. It will internally convert them into Java MapReduce programs, and it will execute them on HDFS, guys. Okay, and what will Pig do? Well, Pig will take simple English-like scripting statements as input. It will convert them into Java MapReduce programs and execute on HDFS, guys. Okay, they're used for analysis. That's why we use our eyes to analyze the world. That's why we can think Hive and Pig as a couple of eyes, guys. Okay, in most of the real world scenarios, what happens is you have different kinds of databases in companies, guys. Some may use SQL Server, some may use MySQL, and some may use Oracle and things like that. Many times what happens, here's what happens, guys. We would like to get the data from these different databases and save it into Hadoop. How do you do that? Well, that's where it comes in Sqoop, guys. Okay, what is Sqoop? That's Sqoop. What will it do? Well, Sqoop will transfer the data from different databases using simple Linux-like commands as input, then convert the input into Java MapReduce programs, and then save the data, transfer the data into HDFS, guys. Okay, the process of transferring the data from a database into HDFS is called importing the data. You can also take the data from here, use Sqoop, and transfer it back to any database. That is called exporting the data, guys. Okay, so what is Sqoop? It's a data transfer tool. All right, and then one more thing, guys. Okay, what is that? Well, the data in the database, it's called structured data. Why? Because you have the schema of the data. What is the schema? Well, if you create a table, generally you know the design. You have the column names, column types, the parents, children, relationship, and things like that. That is called schema. But what's happening today? Well, there is a new database. What is that? That's what the internet is about. Okay, this is the new database. What do we have here? Well, we have lots of varieties of the data. What do companies want to do? They want to get this data and save it into HDFS. What do you use for that? Well, that's where it comes in Flume. Go ahead and put it here. Flume is a tool used for transferring the semi-structured or the unstructured data into Hadoop, guys. Okay, the data on the internet, we do not know the schema, so that's why it's called unstructured data, guys. Okay, we use the tool Flume to transfer the data. All right, and there's another tool, guys. What is that? There is a database of Hadoop. What is that? Well, that is a HBase. Okay, what will HBase do? HBase is used for modification of the data. No other tool is used for modification of the data. These two are used for analysis. This is used for data transfer of structured data. This is used for data transfer of unstructured data, but nowhere can we modify the data. That's where HBase comes in. HBase will directly go ahead and it can modify the data in HDFS. Okay, HDFS or Hadoop is not a database, guys. HBase is the database of Hadoop. Hadoop is a distributed file system. What is a distributed file system? Well, it's a group of computers together. They act as if they are one computer. That's what it is, guys. Okay, I hope that is making sense. And there is also another tool called Uzi, guys. Okay, let me go ahead and put it here. Uzi is a workflow orchestration tool. Most of the times what we will do is we'll end up writing lots of scripts in Hive, Sqoop and all these things, guys. Okay, what then we will do is we will use something like Uzi and we will schedule the scripts to run at times of the day. Maybe every few hours, every few minutes and things like that. What does Uzi do? Uzi will allow us to go ahead and schedule these scripts to run at periodic times. Okay, that is the other tool that we're going to be looking at. And the one other tool that we're going to be covering as part of our course is going to be Spark, guys. Okay, Spark is receiving a lot of attention today, so we'll go ahead and have an introduction of Scala and Spark towards the end as a complementary, guys, of this course. Okay, so what are all these things, guys? These are the framework of tools that are part of Hadoop. Okay, what will Hadoop do? Hadoop helps us in running applications on big data. Alright, it is helping us run applications on big data. So if you have big data, what is happening? There's a problem there. Big data is problem. Why? We'll talk about that in a second, but Hadoop will help us in solving the problem of big data. Okay, traditionally what is happening? Here is what is happening, guys. Let's go ahead and discard that. If you have a lot of data, what companies are doing is they're buying some powerful servers and they're adding more RAM. So let's go ahead and indicate they add more RAM, they add more processors, and they add more hard drive. And what is that? That is called vertical scaling, guys. Okay, the problem with that, there is a limit. You cannot exceed that limit. Okay, so give me 1 second. Okay, so back here. Sorry about the pause. Okay, 1 second. Okay, I'm back, guys. Sorry about that. Make sure this up. And so on. Okay, I hope you guys are able to hear me, guys. So this is called vertical scaling, guys. Okay, it has a limit. You cannot go beyond the limit. That is a problem with the traditional approach, guys. Okay, here is what Hadoop does, guys. What will Hadoop do? Hadoop will take your data. Step one, it will split it into lots of small pieces. Those are called blocks of the data, guys. Okay, so if you look at this one, all right, what do you have? Well, there is your, imagine this is your resume, and you imagine your resume has 4 pages. For the sake of simplicity, let's assume each page is about 64 megabytes, guys. Okay, what do we have? What if you give it to Hadoop? Step one, it will split it into 4 pieces. Okay, for the first page it will call it as block 1, the second page it will call it as block 2, the third page it will call it as block 3, and the fourth one it will call it as block 4, guys. Okay, that is the first step it will do. Then it will take this block. Okay, I'm gonna see, it's gonna take this block and save it here. It's gonna take this block, oops, let's see if I can move that. It saves it there. Similarly, this one, it will save it there, and this one, it will save it there. Alright, what is this called? This is called distribution of the data, guys. Step 1, it split. Step 2, it has distributed the data. Distributes the data on where? On multiple machines, guys. Okay, Hadoop will not will generally use what is called inexpensive hardware called commodity hardware, guys. Okay, and this commodity hardware is inexpensive hardware, and you can use lots of machines instead of one machine. Alright, so that is called horizontal scaling, guys. Okay, but there is a problem here. What is the problem? Well, go here. If one of the nodes fail, then we have lost the data. So in other words, if you come back here, suddenly this node goes down, then, and at this point if I get a request saying that give me my resume, I have page 1, 3 and 4, but page 2 is not there, so that's a problem, right? So what will Hadoop do? Hadoop will go ahead and replicate the data. In other words, it will go ahead and save block 1. It will make a copy of block 1 here. It will also make a copy of block 1 here. So if you look at this one, come back here. Okay, so there's block 1, the first copy, and the second copy is there, and the third copy is there. Okay, so at any point of time, if one of the nodes go down, if this goes down, why will a node go down, guys? Because they're inexpensive hardware, they're commodity hardware. The only thing that they do not guarantee is reliability and uptime, right? So that is why we assume, Hadoop assumes that these nodes can go down at any time. When they go down, what will happen? Well, we should not be at a loss of data. So Hadoop goes ahead and replicates the data. It saves additional copies on other nodes, guys. This is called as replication. Alright, so if one of them goes down, we are not at a loss of data. Okay, so here's what we are showing, and this process is called as fault tolerance, guys. Okay, so what we are looking at is, if one of the node goes down, we are not at a loss of data. We will be able to retrieve the data. That is what is called as fault tolerance, or we are protecting our data, guys. Okay, and one more thing, guys. Okay, so what is it that Hadoop is doing here that we cannot do? Well, Hadoop is simplifying the program, guys. What is happening is, we are not worried. Let's go ahead and we are not writing the code where we need to worry about how these nodes communicate with each other. Okay, if you have your data sitting in multiple nodes, guys, one of the things that you need to understand is, how do these nodes communicate with each other? How do they process communicate with each other? How does the threading work? How does networking concepts work? How does the fault tolerance work? All these concepts, we don't need to worry about them. Okay, Hadoop internally takes care of that. What does that mean? Well, it is simplifying the programming for us. Whether you have one node, whether you have 10 nodes, whether you have 100 nodes, you don't worry about that. You leave it to Hadoop. Okay, it will take care of where it is located and what happens if it fails. Well, that is taken care of by the Hadoop. And how do you break your data when you're dealing with big data? Generally, or in real world, you will end up dealing with multiple terabytes of data. How do you break this data? How do you put the data into multiple nodes that you don't need to worry about it? And how do you scale your data? What if you have today one node, but tomorrow you may increase it to 10 nodes or 100 nodes? Will you need to make any code changes? No. What is that? That is what is a scale-free programs, guys. Okay, so what's a scale-free program? Well, your code is independent of the size of the data. Whether you're writing your code for 1 GB of data or 100 terabytes of data, you will not make a single code change, guys. What you will do, you will just install Hadoop on your servers and leave it to Hadoop. Okay, that is really useful, guys. That is what is meant by scale-free programs. Okay, I hope I'm making sense, guys. Alright, so let's move on to the next example, guys. Until now, come back here, let's have a quick review of what we have seen. So what we discussed is, we started with what is big data, then we have discussed what is Hadoop, how it is used, what is it, and how it internally works, the process of splitting the data, distribution, replication, and fault tolerance. These are all the internal concepts, guys. Okay, that is how Hadoop works. And now we'll see how Hadoop is used, guys. Okay, so here's a quick example of how Hadoop is used in the world of predictive analytics, guys. Okay, predictive analytics is a thing that you will almost hear anywhere today, as it is getting very popular, and the more the data, the more the predictive analytics will be helpful, guys. Okay, so here is what is happening, guys. California, Los Angeles Police Department in California, or somewhere in California state, they're using predictive analytics heavily, guys. Okay, what will they do? Well, they take their entire data for the past 10-20 years, and what do? They run a few MapReduce programs on a daily basis at night, and then during the morning, when the top management, the top police officials come in, What they do is they look at this data, they look at the reports that this data is producing. What do they say? Well, that report says this is spot 1 where a crime is likely going to occur today. It's predicting where the crime is going to occur today. Then this is crime spot 2 where a crime is going to occur, and this is spot 3 where a crime is going to occur. What does that mean? Well, what they will do is they're going to deploy 25% of their police force there, 15% of their police force there, 10% of police force there, and scatter the rest of the police throughout the city. What is it doing? Well, it is helping them in coming up with some decisions in a meaningful way using the data. That is what is big data about, guys. Okay, and if you were to go ahead and process this 15 to 20 years of data, okay, it's going to be very big. What will you do? Well, you'll need to be an expert in many concepts. What is that? Multi-node communication, multi-process communication, multi-threading, networking concepts, and many other things. What does Hadoop do? Hadoop, without knowing all these things, will allow you to write the analytic programs in a very simple way using Hive, and other tools, guys. Okay, so this is one example how Hadoop is used in real world, guys. Okay, and again, I hope that is making sense, guys. The next aspect is how Hadoop is used in a telecommunications domain, guys. Okay, we'll have a quick look at it. Okay, so here is what is going on, guys. Today in telecommunications, there are many companies out there. Many telecommunication companies are there, and what's happening? Well, nobody is using landlines, right? So go here, nobody's using landlines. As a result, their voice calls are going down, right? And every day one new provider is coming up. They're offering very competitive prices. As a result of that, they have to keep their price very low, and they're going down and down. What is happening? Any telecommunication company, guys, okay, has a lot of cost because there's a lot of infrastructure built around the city and all over the locations that they are providing service, right? So what's happening? Their costs are day by day increasing. That's a big problem, guys. Okay, so here's what happens, guys. One day there is a coffee shop which is getting opened up, and that coffee shop one day approaches a telecommunications company and says, hey guys, you know, we keep hearing about this big data and Hadoop, and we want to know if you can help us in any way. Okay, so that's what the coffee shop says. The telecommunications company take on the challenge, and they do some R&D. They try to understand how to use big data, what is it that big data can help, and here is a plan that they come up with, guys. Okay, the plan they come up is they're going to target all the coffee drinkers in the city as plan A. Next, there are lots of people who are located near the coffee shop. They will try to identify all those people. They're going to be targeting all those people who are nearby the coffee shop. Okay, that's plan B. Plan C, social influencers, guys. Okay, if you take the top Hollywood actors, Bollywood actors, and so on, the Tollywood actors, right? These guys, they oops. Okay, apologies, guys. So I have that coming up periodically. Okay, so just an act of devotion. I hope you guys are okay with that. Alright, so social influencer, guys. Okay, so popular guys, when they tweet, when they blog, and when they write something, right, what happens? Well, their message, they have a lot of followers, and their message is reaching many people. What's that? Well, they're a social influencer is what it is. Okay, they're going to be very helpful. How? We'll see in a second. And there is a coffee shop. If you go back here is the coffee shop. Imagine this as a movie theater, guys. Okay, so lots of guys are going to movies on a daily basis, passing by the coffee shop. Okay, so what is the plan? Well, that's going to be the next group of people that they're going to target. All right, so here's what goes on. What will they do? The telecommunications company, after coming up with this plan, they go ahead and talk to a guy. His name is Jim, and they say, hey buddy, we want to access your data, your Facebook access, Twitter, and things like that, and we want to analyze it. So he says, go ahead buddy, what's there in it for me? Okay, why do they contact Jim? Well, imagine Jim is like an actor or a popular guy in that area, and if he writes something on his blog or Twitter, he has a lot of followers there, so his message is reaching. So that's why he's important for the telecommunications company, guys. Okay, what does he do? Here's what he does, guys. The reason they contact him is he's one of the customers of the telecommunications company. Okay, so they have access to his mobile data, guys. All right, what is he doing? Well, here's what he's doing, guys. 8:10 a.m. He wakes up, starts his work. 25, he's having coffee. 3:05, he's having another coffee. He's going to work and having another coffee in the afternoon. Then at 5:30 p.m. he's starting at his work, and 7 p.m. he's going to his movie, guys. These are called the mobility patterns, guys. Okay, so if you look here, what's he doing? Well, he has coffee twice a day. Come here, he's having coffee twice a day, so that requirement is met. And he's passing by the coffee shop. Okay, so because they have access to the telecommunications mobile data, they can figure out the latitude and longitude of his locations where he is, and they figure out he keeps passing by the location of the coffee shop. All right, and he's a popular guy. He writes something, his message is reaching, there's a lot of activities generating on his website and things like that. So he's a social influencer. That requirement is also met, and he's going to the same movie theater right by the side of the coffee shop. So he's a movie goer. That requirement is also met, guys. Okay, so what will happen? The next day he gets a message saying that, hey buddy, you can get a free coffee at our coffee shop. Okay, so what will he do? Well, because he's a coffee drinker, he'll go ahead and gladly have that. Logically, someone like us, if we get a decent from a decent coffee shop, if we get a message, we'll go ahead and have the coffee, right? So that is what he does. And then guess what he does? Well, he come out and says, he opens up his laptop and he starts tweeting about it. Okay, take a look at this, guys. Something very important on this one. He says, I loved that coffee shop. Imagine a popular guy indicates, hey, he loved a coffee shop and things like that. What will happen? Well, that message is reaching many people, guys. Something very important on the screen. Notice that. That is the message that it's reaching that many. It has a probability or a possibility of reaching that many messages. And what happened here? Well, there was just one free coffee offered to him, and the probability increased to that many followers, guys. Can you imagine how many social influences will be there? And if a popular guy is going to a coffee shop, a common man will definitely try to get attracted and will also try to visit that, guys. What will happen? Well, this is what will happen. We'll come and say we like it. The more the likes, the more the better. What's happening? It's kind of indirect marketing which is happening, guys. Okay, so what does that mean? Well, what's happening here is not $1 or not a rupee was spent on media ads or TV ads or banner ads. Okay, just one free coffee, and that's what the marketability that it generates. Okay, if you take this scenario, guys, okay, it can be used in multiple domains. It need not be used just for a coffee shop, but it can be used in multiple domains. Okay, so big data solutions are globally applicable. The problem that the companies are having is they're trying to understand how to use the big data. That is where we come in. That's where the Hadoop developers come in, and they try to help them in analyzing that big data, guys. Okay, I hope that is making sense, guys. I'm going to put you on hold here for one quick minute here. Apologies. I'm back. Sorry about that. So let's move on here. Alright, guys, so here is the final project that we're going to be taking up, and in our final project what we would be doing is we would be using multiple tools such as Hive and Sqoop, HBase, everything together. It will give you a complete life cycle of a Hadoop project, guys. Okay, this is one of the world's largest financial institution in North America. They have a process where they generate lots of e-statements, guys. Okay, what is happening? Well, it takes about 18 to 30 hours per day to complete this process, and during this process, if they happen to make a small mistake, they have to rerun this, and again you need to wait 18 to 30 hours per day. Okay, what will happen? Well, you miss your SLAs. Your customers will be very unhappy about it, and it will lead to their dissatisfaction, guys. Okay, so what does the bank want to do? Bank wants to cut down the processing time. That's their objective one. Then they want to go ahead and reduce the cost. How do you do that? Well, that is exactly what this project is about, guys. Here is the workflow of the existing architecture. We have multiple applications which are sending the data to a central application. That is what this one is, and they put that data in the form of 4 GB of data, and then they start generating the statements and start sending out the alerts, guys. Okay, what is it that they want to do? What is it that we are going to do? We're going to introduce Hadoop here. Okay, so this is where we introduce Hadoop. So now all the applications will start sending their data to Hadoop. This is where we'll use Pig, Hive, Sqoop, and all those things. We'll get the data. We'll write a few scripts in Pig, Hive, and all these tools, and then we'll reduce the time. What is the solution? Well, the solution, we will reduce the amount of time to 1 hour to 10 minutes. Okay, so that is what happened. And here is a quick look at different tools which are involved here. So we'll use Pig to go ahead and process the unstructured data. We'll use Hive to go ahead and generate different kinds of structured data, and we'll use Sqoop to get the data from different databases and save it to Hadoop. And then once the data is there, we'll write a few scripts in all these tools in Pig and Hive, which will process the data, and then we'll use Sqoop to go ahead and transfer the data into HBase, guys. Okay, so it's a complete life cycle of project which involves everything, and we will also as part of our projects try to do a couple of use cases in Pig and Hive, where we will be working on a use case in healthcare, and it's about de-identification of the personal health information, guys. Okay, so that's one use case that we would be doing, and what we would do is we would take a lot of data, we would de-identify the data in HDFS. De-identification is a process of encrypting your data, guys. Okay, because it is very sensitive data about the patients. And the other use case that we would be dealing with is the Flume and Twitter's use case, guys. Okay, Twitter is a pretty popular site. Okay, earlier, if you remember, I referred saying that internet is your new database, right? What is happening? Well, lots of companies want to get the data from internet. What is that? Well, I want to get the data from Twitter, I want to get the data from Facebook, and many other sources. How do you get them? That's where comes in Flume. Flume, once we will act as a bridge between the internet and our HDFS. We get the data, we save the data in HDFS. Once you save the data in HDFS, we'll start writing some scripts in Hive and analyze the data, guys. Okay, different ways we'll try to analyze the data. That's going to be one of the POCs that we are going to be looking at. So what is all this, guys? Okay, why is this important? Well, big data is helping the companies in becoming more smarter, guys. Okay, the more the data they analyze, the more the predictability, the more the probability, and it will allow them to make much better decisions. It is about, okay, they're making it much smarter. And the different domains where you can use big data and Hadoop, you name it, in almost every domain, guys. Okay, big data is applicable. It's not that it's only applicable to healthcare, but you can name it even in government, education, and everything, and it is growing, guys. If not today, tomorrow, everyone is going to touch big data. The moment you touch big data, guys, the solution, your default solution is Hadoop. Okay, so that is what this one is about. And here is a look at different locations around the world where Hadoop is used, and currently lots of jobs in US, UK is growing, India also it's picking up, guys. The good news is whenever it grows in US, they find we're directly proportional to them. So in other words, as the jobs grow in US, you know, the associated jobs, the similar jobs tend to grow in India, because we come at a much reasonable price and a high quality of resources. That is also good news for those who are in India, guys. Okay, but first-hand information, lots of opportunities in US, guys. Okay, so I hope that made sense, guys. So before I wrap up, let me quickly go back here and give you a quick I'm gonna hide them, and that's module 2 and module 1 and module 2. I think I need to hide that one. So that's module 1 and 2, guys, and week 1, right? So up to here. That's module 1, and this is the module 3 up to, let's go here. Okay, so let's see if I can leave one there. So that's our module 3 and 4. We will cover this in the second week, guys, and then comes our module 5 and module 6. I'm going to hide them. So that's week 2, that's week 3. I think Hive, I have also hidden Hive here. Week 3. Go ahead and select that. That's week 3. One more time, I'm going to select that. And select that. I'm going to hide that. And from there to there, that's your week 4, guys. It's going to be a 6-week course. I'll select that one. In week 4 we'll cover HBase and Sqoop, and if it's really necessary we will go ahead and also try to take some additional courses if it is necessary, guys. Okay, so I'm gonna hide that. I'm also gonna hide that. Okay, that's week 4, and that's going to be the final project, and at the end we'll go ahead and take up Scala and Spark, and once I give you a start of that, it will be pretty, you'll find it pretty helpful, guys. Okay, that is the objective of us offering that course. Okay, so that's about the demo, guys. I hope you have found that useful. Please feel free to get in touch with our kernel training, and you can go ahead and ask if you have any additional questions and things like that. Let me go ahead and kerneltraining.com, that's our website, guys. Let me give it a second here. These are some of the courses in plan, and please feel free to get in touch. There's a contact us link, and I think you can send us email, you can give us a call if you're located in India, and just send us a message here. We'll try to get in touch with you, guys. Okay, with that I will go ahead and wrap up this one, guys. Thank you for attending the demo. I appreciate it, and please feel free to get in touch with us if you need any additional information, guys. Thank you.